Welcome to V-Guide TV. In this video, part 3 of current electricity, I am going to discuss what are the factors depends on resistivity or how the temperature depends on resistivity. Before watching the part 3 video, you have to watch the part 1 and part 2 video of our current electricity. In the previous video, I told you the resistivity and the resistance relations with length and area. So resistivity is independent of length and area, whereas resistance depends on length and area. But both resistance and resistivity depends on temperature. So I can write a relation of resistivity depends on temperature as rho T equals rho naught into 1 plus alpha into T minus T naught. Rho T means resistivity at temperature T. Rho naught means resistivity at temperature T naught. Alpha is called temperature coefficient of resistance. T is the final temperature, T naught is the initial temperature. The same equation I can write in terms of R as R equals R naught into 1 plus alpha into T minus T naught, where alpha can be positive for metals and alpha is negative for semiconductors. And alpha we can find by a relation. If you arrange this term, I can write alpha equals RT minus R naught by R naught into delta T. RT minus R naught by R naught into delta T. Now, see, I want to recollect a small thing from 11th class. In 11th class, thermal properties of matter we learn as the temperature increases, length of the body may increase, area of the body may increase, the volume of the body may increase. So, I have written a relation that delta L equals L alpha delta T. Delta L equals L alpha delta T. Are you remembering? If you check that equation with this equation, they are similar. So instead of delta L, here I can write delta rho. Instead of L, here I wrote rho naught, alpha into delta T. So you can recollect the equation like this. Delta rho is equal to rho naught alpha delta T. So the meaning is as the temperature increases, the resistivity also get increased for a metal. But for semiconductor, it's not like that. I'll discuss in the next slide. And if you see this equation, you can tell that the numerator unit is ohm, denominator ohm into Kelvin. Ohm get cancelled and the unit of alpha is Kelvin inverse. So you have to remember this equation. This equation I told the shortcut way to remember delta L equal L alpha delta T. Instead of that, you write delta rho is equal to rho naught into alpha into delta T, where alpha is called temperature coefficient of resistance. Now, in the previous video, I told you I derived an equation for resistivity. You watch part 2 video. So, in that, I discussed the resistivity as rho equals m by Ne square tau, where m is mass of the electron, n is the number density, E is the electronic charge and tau is the relaxation time. And just now I told the resistivity depends on the temperature. So this is the variation of resistivity for conductors and semiconductor. If you take conductor, as temperature increases, the current get decreased because the resistivity increases. Why resistivity increases in metal means as the temperature increases, the atoms or the electrons start to collide very fast. So when the electrons starts to collide very fast, the relaxation time get decreased. Relaxation time is nothing but the time interval between two successive collisions. So this relaxation time get decreased. So this relaxation time term is in denominator. As this term comes down, rho get increased. As rho get increases, current get decreased. So I wrote in a short form, as temperature increases, current decreases because resistivity increases and the tau get decreased. Clear? So remember two things. That is the reason in the previous slide I wrote alpha is positive because I should get more resistivity as the temperature increases. For that, for this equation, I need alpha as a positive term. But if you take a semiconductor, same thing will happen as the temperature increases. Current also increases. As why current increases? Same thing happen means what I want to tell? The tau is getting decreased here and here. So in this case also tau decreases, but here also tau get decreased. But in semiconductor, as temperature increases, N is increasing, number density getting increased. As a number density get increasing means that is overtaking or decreasing tau. So that is the reason as temperature increases, current also increases. Because resistivity decreases of two reasons. Which are the two reasons? One is N increases. Number of electrons, free electrons are getting increased. Why? Because temperature increase. So N increases and tau decreases. So decrease in the tau is overtaking by increase in the N. So if I need resistivity should decrease with increase in temperature means surely in this equation I need minus here. So that is the reason I am telling alpha is negative. Very important concept here. Okay, how the resistivity varies for a conductor and a semiconductor. For a conductor, resistivity increases with the temperature, but for a semiconductor, resistivity decreases with temperature. Clear? Next, I am going to discuss about the color codes of the resistor. Color codes of the resistor means you know that the component which offers resistance are called resistors. How will you identify the value of resistance? By seeing their codes. So each resistor have a set of colored bands will be there. So for a resistor we have 4 colored bands. Out of 4 colored bands, the first 2 band or the first 2 ring we write as significant digit, and the third one we write as decimal multiplier, and the 4th ring we write as tolerance. So first and the second ring are significant digit, third one is a decimal multiplier, 4th one is a tolerance. Then how will you understand the significant digits? For that I gave a tabular column here. In this tabular column there are 4 columns here: color, number, multiplier, tolerance. Color means you write black, brown, red, orange, yellow, green, blue, violet, grey, white, gold, silver and no color. Okay, so I gave the colors like this. And I told you you can understand the numbers as 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Like number you can write it. Multiplier you can write 10 power 1, 10 power 0, 10 power 1, 10 power 2, 10 power 3, 10 power 4, 10 power 5, 10 power 6, 10 power 7, 10 power 8, then 10 power 9. Next is 10 power minus 1, another one is 10 power minus 2. Tolerance means you can write like this: plus or minus 5%, plus or minus 10%, last one is plus or minus 20%. Okay, then it means the first 2 digits, the first 2 colors we are writing like a significant digit only, directly we are writing the digit. Third ring means you write in the form of this multiplier. Fourth ring means you write in the form of tolerance. So here by seeing this column you can understand that tolerance means only 2 possibilities. Maybe gold or silver, or no color means we can't understand the color, right? So gold and silver color can come for the tolerance. So what I told you, for a resistor color code we have 4 colored bands. First 2 colored bands you write significant digit. Third ring you write as a decimal multiplier. I have given here the decimal multiplier of each colors. And the last ring, that means 4th ring, indicates the tolerance. So 4th ring possibilities are gold and silver, or there may not be any color. How to understand or how to remember these colors? For that a shortcut is there. B.B. Roy of Great Britain has a very good wife who wears gold silver necklace. So it means that I'll tell a shortcut. You just write all the colors first letter as capital digit here. BBROY, I've written capital. Great G capital, Britain B capital, very V capital, good G, wife W. Gold and silver necklace. Gold is gold only, silver is silver, necklace means no color. Then you start the number from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Up to 9 it will come. Okay, and these two you remember, gold and silver. After this, here many people will make a mistake. You may forget B. First B is which B? First is black, then brown. 0, 1. Again one more B is there, that is blue. Then two G's are there. One is green, other one is grey. Okay, so you remember it like this. I'll give a shortcut how to do it. See the question here. I gave a question here. It has, if you see the question, it is like this only. Violet, yellow, blue and silver. You have to check violet, what is the number? 7. Yellow, 4. So 7 and 4, write it like that only. 7, 4, that is 74. Third is blue. Blue color is 10 power 6. So that you write as a multiplier. So 10 power 6. Silver means plus or minus 10%. So I can write 76 into 10 power 6 plus or minus 10%. Another one is simple one I gave. Red, red, green, gold. Red, red. Red means 2. Red, red, 2, 2. So 22. Green. Green means 5 means 10 power 5 into 10 power 5. Gold. What is the percentage of gold? Sorry, it's a gold only. So it is 5%. So we can write 22 into 10 to the power of 5 ohm. But the variation can be plus or minus. How much percentage should be there? 5%. Clear? Because I gave here as the gold. So in this way, we can find the resistance of a resistor by using color code. So color code, I'll repeat again. In a color code, we have 4 colors. First 2 colors write as significant digit. Third one write as a multiplier. Fourth one write as a tolerance. And remember this. Okay, column you remember. For column shortcut I told you BB Roy of Great Britain has a very good wife who wears gold silver necklace. This is a simple question. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of silver. What is your resistance equation? RT equals R0 into 1 plus alpha into delta T. RT means resistance. What is the resistance here? First, at 27 degrees Celsius, 2.1. At 100 degree, 2.7. So I am just writing 27. Resistance at 27.5 is R0 into 1 plus 27.5 into alpha. That is 2.1, equation number 1. If you see the second one, for 100 degree, it is 2.7, that is R0 into 1 plus 100 alpha. Divide these two equations, R0 get cancelled. So 1 plus 100 alpha by 1 plus 27.5 alpha equals 2.7 by 2.2. So I got answer alpha equals 0.0039 per Celsius inverse. I hope you understood this video. I discussed about the color code of resistance and I discussed the very important thing, how the resistivity varies with temperature. And for conductors alpha is positive, for semiconductors alpha is negative. And I gave you the relation of resistivity with the temperature. Rho T is equal to rho naught into 1 plus alpha into delta T. Hope you like this video. If you need more videos, subscribe our channel V Guide TV. Thank you.